Yeah, welcome to a very simple tutorial on analytical hierarchy process. Now, HP is an example of HP is an example of multi-criteria multi-criteria decision-making process or methods. HP was developed as a modification of both WSM, that is weighted sum method, and weighted product method. As weighted sum method and weighted product method both cannot compare the significance of the alternatives, which are qualitative in nature. That is why this AHP method was invented or innovated by Saaty, and the by qualitative criteria I mean, say for example, style of a car. Now, you cannot represent the style of a car with the help of any numbers. You must rate a style of a car. You can either say it is very good, very bad, bad, or neither good, neither bad. But you cannot give a specific number. Just like, for example, cost. I can say the cost of this alternative is rupees 250. Yes. This alternative is rupees 150. And this alternative is rupees 200. So majorly generally we take the lowest cost as the most preferred alternative, and you can just compare the magnitudes. You can easily see that this is the most preferred alternative because it has the minimum cost. But the same way we cannot choose the best alternative with respect to the criteria style. In case of style, you have qualitative ratings. You can either score it by a scale. Say for example, if you want to score one alternative or all the alternative with respect to a scale of 100, then you can rate the best alternative to be 80%, the second best alternative to be 70, and third best alternative to be 50, and so on. But you can note that these ratings will change with the change in the decision maker. If I am rating these alternatives, then I will give this rating. But if you are rating this alternative, you may give some other ratings. So the ratings is different for different decision maker. So that is why in case of AHP, we have the concept of rank. So what we do is, in case of AHP, we rank the alternatives with respect to their preference for each of the criteria. So for example, let us say we want to purchase a car, and here I have a criteria cost, and criteria speed. So suppose there are three alternatives: Maruti, then this is let it be Jaguar and Toyota. Now cost of Maruti is rupees 3 lakh. About I am randomly assuming that. Jaguar is around 20 lakhs and Toyota is around 18 lakhs. This is assumption, may not be same as the original price. And similarly, just assume speed of Maruti to be around 120, these to be 250 and these to be 270. Now, in case of HP, first step will be we have to find the significance of or weightage of importance for the criteria. Now, if with respect to me, cost is more important than speed, then this will be your rank. Cost will have the highest preference rank and followed by speed. Now, as this rank or this rank is not proportionally, rank cannot show the importance of the criteria in a proportionate manner. That is why what we do is we try to find the complement of this rank. How to find it? If there is n number of criteria or the alternative, in case of alternative also we use the same formula. So to find the complement of the rank, we add 1 to the total number of criteria, deduct the rank of the criteria. So in case if it is cost, the rank of criteria is 1, so let it be n plus 1 minus 1. And then we divide it by n plus 1. So here you see the total number of criteria here is 2. So this will be, the numerator will be 3 minus 1 divided by 3. So this comes to be 2 by 3. So it is around 0.667. And another one, which our rank 2, here also 3 minus 2 and divided by 3. So this will become 1 by 3. So this will be around 0.53. So 0.333 and 0.667 is the complement of rank 1 and rank 2 if there are 2 number of criteria. If there are 3 number of criteria, then 3 plus 1, 4 minus 1 divided by 4 and so on. Now our next step will be to compare each of the criteria. Compare each of the criteria, or rather I will say compare the importance or significance of each criteria with respect to the other criteria. So this is also known as pairwise comparison matrix or PCM, where we compare the importance of criteria with each other. Now, for example, when I compare the criteria of C1 with respect to C1, then it will be certainly 1. And C2, this is 1. However, for the importance of C1 with respect to C2, so what is the complement of rank for C1? It is 0.667 and divided by what is the complement of C2? That is 0.333, right? Because we are comparing the importance of C1 with respect to C2. So the criteria for which we are estimating or approximating the importance will be in the numerical, and the criteria for which or with which we are comparing the importance, that will be in the denominator. In the second row also you see C2, the importance of C2 with respect to C1. So it will become 0.333 by 0.667. So now after this step, what you will do is you will straight away find the geometric mean of this row and also the geometric mean of second row. How to find the geometric mean? Root over this 1 multiplied by 0.667 by 0.333 root over of, as there are two number of variables, so it will be root over of 2. If there are three number of variables, this will be root over of 3, and so on. Now you will find the geometric mean of the row 1 and row 2. After that, what you will do is you will add GM1 plus GM2 to find the summation of these two GM, and you divide this summation of GMs with each of the GM. Now this will give you your weightage of criteria. This will be for C1 and this will be for C2, right? Now in similar manner we have to find the normalized output of the alternatives also. So here there are three alternatives. Suppose there are Maruti, Jaguar and Toyota, and with respect to cost, I have already discussed about the what is the cost. It is just arbitrary values, 3 lakh, 20 lakh, 18 lakh. These are all arbitrary values. And for speed also, this is also an arbitrary value. Just for example, I am taking. Now what we will do is, first we have to find the weightage of importance of each of these alternatives with respect to the other alternatives for the criteria cost as well for the criteria speed. So what the first step will be to rank the alternative with respect to cost. Now lesser the cost, more preferred will be the alternative. So in cost, this Maruti will have the best rank, followed by Toyota and then to Jaguar. But in case of speed, higher the speed, more is the preference. So you give highest rank to Jaguar, followed by Toyota, and the last rank will be for this Maruti. Now you have find out the rank. Now as usual, similar to the criteria matrix, we will find the complement of all these rank. Okay. Now, as usual, there are three number of alternative here. So to find the complement, this is for Maruti with respect to cost 4. So it is 3 by 4, right? It is 3 by 4, and the fraction, the result will be 0.75. And for this Toyota with respect to cost, this will be 2 by 4, and the fraction will be 0.5. And for Jaguar, this will be 4 minus 3 by 4, that is 1 by 4. So this will be basically 0.25. And for speed, this will be your 0.25. This will be your 0.75. And these will be your 0.2. Now, what we will do is we will just compare each alternative with respect to the other, and let us use the example. Let us say Maruti, Jaguar and Toyota with respect to Maruti, Jaguar and Toyota cost. What cost? Now as usual, Maruti, importance of Maruti with respect to Maruti will be 1. Importance of Jaguar with respect to Jaguar will be 1. Importance of Toyota with respect to Toyota will be 1. So, but importance of Maruti with respect to Jaguar will be 0.75 by 0.5, and for Toyota it will be 0.75 divided by 0. This is 25, 0.25. Now here also, just like the criteria matrix, you have to find the geometric mean of this row, this row, this row. And geometric mean for here will be 1 multiplied by 0.75 by 0.50 multiplied by 0.75 by 0.25 to the power 3, because there is 3 variables here. At that time there was 2 variables, but for this there are 3 variables. So for Maruti you will get 1 GM, for Jaguar you will get 1 GM. The C subscript indicates the cost. This is for criteria cost. And for Toyota you have another G. Now, similar to the criteria matrix, you will just add these numbers, these geometric means, to find the summation of the geometric mean, and then divide each of the GM geometric means with the summation. Now, as usual, just like the criteria matrix, the result of this division will give you the weightage of significance of the alternatives with respect to the other alternatives for the criteria cost. Okay, so now in the similar manner, you will again compare the alternatives Maruti, Jaguar and Toyota with respect to Maruti, Jaguar and Toyota, but this time for speed, right? So Maruti, Jaguar and Toyota is same. So the complement of rank with respect to speed for Maruti, as we all know, is 0.25 divided by, I think it is 0.5, and for Toyota it is 0.25 by 0.75. Now similarly for Jaguar Maruti, it is just the opposite of this one and this one. That means 0.5 by 0.25, and this will be Jaguar Toyota. So I think Jaguar have the complement of rank as 0.5 and Toyota has the complement rank of 0.75. And in the last row, we will find the importance of this Toyota with respect to the other alternatives. And for the criteria speed, here as you can see, this will be the complement of the already calculated ratio. For Toyota with respect to Maruti, we have already calculated Maruti and Toyota. So this, the opposite will be there, 0.75 by 0.25. And for Toyota it is 1, but for Toyota and Jaguar, this has already been done. So this will be your 0.75 by 0.5. Now here also you have to find the geometric mean of each of the rows. To find the geometric mean of Maruti with respect to speed, geometric mean of Jaguar with respect to speed, geometric mean of Toyota with respect to speed. And again you will add each of the GM with the other, and you will find the summation of the GM, and then you divide each of the GM by this summation. This will give you the weightage of importance or weightage of significance of each of the alternatives with respect to speed. So for the earlier previous matrix, you have calculated the weightage of importance of each of the alternative with respect to your criteria, cost, and in this matrix what you have done is you find the weightage of significance of each of the alternative, but now it is with respect to speed. So let us name them as, and giving the name, now the last step of AHP will come, where what you will do is, you see here we have already have the weightage of each of the criteria, and also the weightage of, sorry, here there is only two criteria, and also the weightage of each of the alternatives with respect to criteria 1, which is cost, and with respect to criteria 2, that is speed. So These we have named as these we have named as and these to be this. And this same thing for speed, that is the criteria 2. So this is over. So we know the weightage of significance of the criteria as well as alternative with respect to this criteria. Now what you will do is you will multiply the weightage of alternative 1 with the weightage of importance of criteria 1. Then you add it with the product of weightage of alternative 1 with respect to criteria 2 and the weightage of significance of criteria 2. So this will give you the product of importance of the alternative 1 with respect to the weightage of significance of the both the criteria. So weightage of alternative 1 multiplied by weightage of criteria 1 plus weightage of alternative 1 multiplied by the weightage of importance of criteria 2. So let us say this is your A1 weightage. Similarly, the weightage of significance of alternative 2 with respect to criteria 1, multiply it with the weightage of significance of criteria 1 plus weightage of alternative or weightage of significance of alternative 2 multiplied by the weightage of significance of criteria 2. So add this and you will find yes. Similarly, weightage of significance of alternative 3, multiply it with the weightage of criteria 1 or weightage of alternative 3 for criteria 2, multiply it with the weightage of significance of criteria 2 and then add it and you will get this. Now just add all the A1 weightage, A2 weightage and A3 weightage to find the summation of these multiplications and then divide the summation to each of the individual products by the summation. So divide A1W by AS, A2W by AS, A3W by AS, and this will be your weightage of alternatives 1. This will be your weightage of alternative 2 and this will be your weightage of alternative 3. And among this alternative, the weightage of alternatives, if you compare the alternative with maximum weightage will be your most preferred alternatives. So suppose weightage of alternative 1 is highest compared to other two, then the most significant alternative will be alternative A1. So for this A1 weightage of alternative 1 must be greater than weightage of alternative 2 and weightage of alternative 3. So then A1 will be the most preferred alternative among these three. If A2 is the largest, then A2 will be the most preferred. If A3 is the largest, then A3 will be the most preferred alternative. Now this is more or less the AHP method is. Here an example application is also explained. But just note that here we have used the rank method. However, the inventor of this method Saaty used its own scale of 1 to 9, where the 1 is assigned to the least significant and 9 is assigned to the most significant at the time of comparing one criteria with respect to the other or one alternative with respect to other. However, the problem with this is, even for a same decision maker, for two different pairwise comparison matrices, the assigned rank may be different. For example, suppose if A1, A2, A3 is there, and then A1, A2, A3 is there for cost. Now A1, this A1 versus A1 will be 1, A2 versus A2 will be 1, A3 versus A3 will be 1. Now when comparing A1 with respect to A2 for cost, we all know that A1 is most preferred because the cost of A1 is least, and we always prefer a product which have a least cost. Generally, that is the practice. So now to represent the importance, the comparison of importance with A1 of importance of A1 with respect to A2 with the help of Saaty scale. Here you cannot just find the ratio of the complement of rank. Here you have to give us number which represent the difference of significance between A1 and A2. As A1 is much significant than A2, so we can give 8 to them. Now A1 is A3, A1 versus A3, so it is much significant than A3, so you give, but not more significant than A2, so we can give it as 7. And here also you see A2 versus A1, that will be the just the inverse of this, A1 A2 A2 A1, so this will become the 1 by 8. And here A2 A3, so they are both not highly different because this cost around 20 lakh and this cost around 18 lakh, so not much difference between them, so you can give a rating of 5. And in case of A3, you see already we have calculated the comparison. A3 with respect to A1, here you see 7, so this will become 1 by 7. For A2, A3 versus A2, A2 versus A3 is 5, so this will become 1 by 5. And now, then the same process is followed. Find the geometric mean, geometric mean, geometric mean. Then find the normalize. That means add all the geometric mean of the row, each row, and divide each geometric mean with the summation. So, but the problem is, in this case, you see, if I consider the speed matrix, this matrix become what? Suppose this is for speed. A1 versus A2, here you see, I have said it is 8. 8 times. A1 is 8 times more important than A2. Because A1 cost only 3 lakh and A2 cost around 20 lakh. So they are there is much difference. Here you see A1, the speed of A1 is only 120 km, but speed of A2 is around 250 km per hour. Now here you can write 8, or you can write 9, or you can write 7. It is up to you. So here comes the inconsistency, that with the most important alternative with respect to the second most important alternative, in case of Saaty scale, for cost I am giving 8, but for speed I can give any number. Here also I can give any number. It may be 8, 9, 7, whatever the may be. It is up to me, it is up to decision maker. So you can see that this decision and this decision, or this rating and this rating, is not consistent. But when you calculate when you first calculate the rank of importance and then find the complement of rank and then use it for pairwise comparison, there is no chance of inconsistency. Okay, so basically what I have taught is a modified method of AHP that was invented by Saaty, and for this inconsistency for AHP with Saaty's method, after the last step we need to calculate the consistency ratio of each of the weightage of the alternative after the last step, as there are inconsistency in rating when we use the Saaty scale. But if we do not use Saaty scale and use the method that I have discussed here, then you do not need to calculate the consistency ratio. So advantage of what I have taught and what Saaty has invented is, in Saaty's case, you have to calculate another extra step after the last step, after finding the weightage of alternatives. But in our case, we do not need to calculate the consistency ratio because there is nothing inconsistent here. So you can go through the presentation. Whatever I have discussed, this is just that. You can either listen to my lecture or you can go through this presentation, and you will learn how to find the best alternative out of 3, 4, 5, anything with the help of AHP. Now this is the Excel sheet that was used for the example problem. If you wish, you can download it. So yeah, you see here we have used the rank, then to complement. Now after that comparison, so and so on. This is just a simple example where we show that which wave energy converter is best. Okay, which wave energy converter is best with respect to cost of installation, protection of shore line, distance from electrical grid, these three criteria. So you can go through this example, and here you see here number of alternative is no. Here number of alternative is 1. Here number of alternative is, as you can see, 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4. So number of alternatives is 4. So you can just add n plus 1. So this is 5 minus then 1 by 5. Here what happened is, here a little bit difference was there in this method and this. Here we have just deduct the n plus 1 value from the rank of importance. We have not divide that rank of importance by the n plus 1. So more or less they are same. You can use this one, or you can just 5 minus 1. So this is actually, we say it as absolute complementing. If I just deduct the rank from n plus 1, and what I have discussed is relative complementing, where what we do is 1 divided by n plus 1. So this is all.